Hello and welcome. I am Dr. Pauline Fu. This video will continue with the last video about hypothesis test about two population proportions. Remember in last video, I gave you introduction about hypothesis test about two population proportion. Okay. We discussed two approaches. One is classical approach, the other is p-value approach. In this video, I will present specific examples to illustrate those two approaches. So example one, an economist believes that the percentage of urban households with internet access is greater than the percentage of rural households with internet access. He obtains a random sample of 800 urban households and found that 338 of them have internet access. He obtains a random sample of 750 rural households and found that 292 of them have internet access. Test the claim at 0.05 level of significance. So let's analyze this question. First, there are two populations involved. One population is urban households. The other population is urban. No, this is urban household. The other is rural households. So two populations. And also there are two samples. One sample is sample size N1 is 800 and X1 338. The other sample size N2 750, X2 292. Okay. Once you have those two samples, you can calculate sample one proportion P1 hat. By definition, it is X1 over N1 338 over 800. And the second proportion P2 hat, X2 over N2, X2 292, N2 750. Okay, and you may also need the pooled proportion, P bar pooled proportion, maybe P hat. Okay, pooled means X1 plus X2 over N1 plus N2. $338 plus 292 over 800 plus 750. Okay, so those are the numbers are given, or we calculated from the given numbers. And then the question asks you to claim, test the economics claim. Okay, what is his claim? He claims that greater than the percentage of urban households, greater than the percentage of rural households. Here you have keywords greater than, so it must be a right tail test because you have keyword greater than. Okay, it's right tail test, and alpha is here. Alpha is the area. This right tail area is alpha. And when you use classical approach, you need a critical value. So when you have a right tail area 0.05, and this is a one-tailed test, the question is, what is this critical value? They have alpha. So this is the point, they alpha. You can use Excel to do it, or you can use a formula. So let me use Excel first. So I put the result here. So we want to find the critical value. So norm dot INV. Okay, INV means critical value. Probability 0.05. Mean is 0. Standard deviation is 1. This is standard normal distribution. Okay. Actually, the formula is based on when you use normal distribution, the probability is based on the area to the left. So instead of 0.05, I need to type in 0.95 as the probability. Okay, as the probability. So I'm going to copy this, Control C, and then Control V. Okay, so what I want to get the critical value. Okay, so the result is change 0.95. If you 0.05, you get a negative number. It is left tail test. So you get 1.645. Okay, so this number equal to 1.645. So critical value Z half alpha. Z alpha, because it is one tail, not half alpha. Just Z alpha. Z alpha equal to 1.645. That is your critical value. Use Excel, you get Z alpha. And if you want to use the table, so go to the table. This is the Z test. So you go to the normal table. See, the table is based on area to the left of this Z. Okay, and now you have the picture like this because you are given right tail area is 0.05. Naturally, this part is 0.95. And this table is constructed based on this way. Okay, this is the area. So locate where is 0.95 here. Found a number that it is 0.95. It is maybe I need to increase the font size. I can see it. You may not see it, but you have this table. I cannot find exactly 0. Yeah, it's here. But if I scroll up, I cannot see the top. Never mind. But what I'm trying to find, I try to find 0.95. 1645. 0.95. Okay. See, I found these two numbers. 0.95 is between these two numbers. And then you get from this number, you go to the left, you got 1.6. These two numbers, you go up. See, you got 0.04, 0.05 together. this point is 1.645. Okay, so if you have this picture, this point is 1.6 identified here. Okay, it's between 0.04, 0.05. So this is the table method. You get the critical value. Right. So I'm here. So far I haven't conducted hypothesis test. I have just analyzed the given numbers and did something for the given number. For example, I calculated sample 1 proportion p hat, sample 2 proportion p2 hat, pooled proportion p hat, and I calculated critical value 1.645. Now everything is ready. I'm going to go to two methods. One, classical method. Two, p-value method. Okay. But before we do that, we must verify the requirements are satisfied. Okay. Remember the requirement have three. One is simple random sample. We always assume this is true. The second is N1 P1 hat times 1 minus P1 hat must be greater than 10. N2 P2 hat times 1 minus P2 hat greater than 10. Remember we calculated P1 hat, P2 hat. Okay. And the sample size is less than 5% of the population size. Okay. So three requirements are met. We go step one, state the null hypothesis. So P1 represents population 1 proportion. So who is population 1? The urban household is population 1. Okay. And who is population 2? Rural household is population 2. So this is P2. And this is population 1. Okay. Because the economics, the person claim greater than, see the keyword greater than, okay. So H1 means you have a greater sign because of greater than. This H0 at H1 is the same as this one here. P1 minus P2 equal to 0. Or P1 minus P2 greater than 0. So that is step 1. Step 2, specify alpha. This value is given. Step 3, calculate test statistic Z. Okay, so remember the formula is P1 hat minus P2 hat. So this is P1 hat. Maybe I'll write on the side. So test statistic Z or Z0. P1 hat minus P2 hat over square. This is the P hat pooled variance. 1 minus P hat. And then times another square root. 1 over N1 plus 1 over N2. Okay, in the previous slide, I identified, say, what is P1 hat, P2 hat, and P hat. Okay, so you just plug in the related numbers and you get test statistic is 1.33. So that is the test statistic. Now, once you have test statistic, remember we also calculated the critical value. This point is a critical value, 1.645, because rejection region or critical region equal to alpha, 0.05. Okay, we use the Excel method to get 1.645. We also go to the table to find 1.645. And now, label your test statistic 1.33. 1.33 is smaller than 1.645. So it must be on the left of 1.645. Okay, so from this diagram, it clearly shows that test statistic is not in the rejection region. Critical region is the same as rejection region. Rejection region. If a test statistic is not in the rejection region, you conclude do not reject H0. Do not reject H0. Okay. So do not reject H0. This is H0. Do not reject means the two population proportions are not statistically different, means they are the same. Two proportions are the same. You do not reject H0. Okay. So that is a classical approach. Next, p-value approach. Okay. Remember what is the p-value? P-value is the area corresponding to test statistic. Okay, related to test statistic. So in the diagram, you label the test statistic 1.33 because this is one-tailed test. P-value is the area, right tail area related to 1.33. Okay, and how do I find this p-value? Okay, I can use Excel to find this p-value, but Excel is based on both Excel and the table, based on area to the left, based on this area. So when you use Excel, if you want to try to find this right tail area, you have to use 1 minus this area. 1 minus this big area, you get the right tail area. Okay, so I'm going to use Excel to do this. Okay. I'll write down here. So equal to 1 minus, okay, norm dot dist. Dist means area. Okay, x is 1.33, mean is 0, standard deviation is 1, accumulative yes. Yes means 1, accumulate. Okay, so that is the formula. Press enter key, you get 0.092. Okay, 0.09 if you keep 2 decimal places. See here. Okay, so that is the Excel. Similarly, you can use the table, okay, to find this p-value. So we get the p-value 0.09 from Excel. Okay, p-value 0.09, and this p-value smaller than alpha, because alpha is given 0.05. When p-value smaller than alpha, do not reject H0. Same conclusion as we got from classical approach. Do not reject H0. Okay. So last step, we conclude That is, remember when we do conclusion, you use double negative to state do not reject, means insufficient evidence to conclude that the percentage is greater than, one percentage is greater than another percentage, means those two percentages are the same. So this is two approaches to test hypothesis test about two population proportions. Next, we'll use another method to test two population proportion. This method is called confidence interval for difference between two population proportions. So what do we want? We want to construct a 1 minus alpha times 100% confidence interval for the difference between two population proportions. When alpha is 0.05, and this becomes 95%. So we want to construct 95% confidence interval for the difference between two population proportions. And then first, we must state the requirements. 3 requirements. 1, samples are independently selected. 2, N1 P1 hat times 1 minus P1 hat greater than 10. N2 P2 hat times 1 minus P2 hat greater than 10. Number 3, sample 1 size smaller than 5% of population 1 size. Sample 2 size N2 smaller than 5% population 2 size. This requirement to ensure the independence necessary for a binomial experiment. When you construct, for example, 95% confidence interval estimate, usually you need to specify lower bound, upper bound. Those two are the formulas. So you use P1 hat minus P2 hat minus Z half alpha times this square root. And the confidence interval only apply for two-tailed test. Okay, two-tailed test. If you just have one tail, you cannot use confidence interval to do the test because the critical value here use Z half alpha. Half alpha means it is a two-tailed test. Okay. This is an example. This example similar to the example we just gone through, but without the keyword greater than. That means this is not one-tailed test. This is a two-tailed test. That's why we can use confidence interval. It's exactly the same numbers. So economics obtains a random sample of 800 urban households and found 338 have internet access. And then he obtained a random sample of 750 rural households, found 292 have internet access. And the question asks you construct 99% confidence interval for the difference. See, difference means it is two-tailed test between those two proportions. Okay, so what we need to do, we need to find P1 hat, P2 hat, and Z half alpha. If we found those 3 numbers, we can calculate lower bound, upper upper bound. Okay, remember we already did P1 hard, so I'm going to briefly to find the confidence interval. We need to calculate lower bound, upper bound. So we need to calculate in this example what is P1 hard. P1 hard is x1 over n1. So 800 is n1, 338 is x1. Next, I will compute P2 hard, x2 over n2. 292 is x2. 750 is n1, n2. So I calculated P1 hard and P2 hard. Next, I will calculate Z half alpha. Okay, Z half alpha. Because this is two-tailed test, how do I know it is two-tailed? The keyword difference. This is one indication. The other indication, the question asks you to construct confidence interval. Confidence interval only applied for two-tailed situation. Okay, and you are given 99% confidence interval. Once you are given 99%, you can get alpha. Alpha equal to 1 minus 99%. So alpha equal to 0.01. Once alpha 0.01, because this is a two-tail test, and each tail, it is just half alpha. That's why the critical value has subscript half alpha. So half alpha equal to 0.005. Okay, there's another half alpha here. So this point is Z subscript half alpha. And this point is Z subscript is negative Z subscript half alpha. Our task is to find what is this Z half alpha. Okay. Again, you can use the formula tables. You can use normal distribution table to find out, but I would use Excel. Okay, so when I use Excel, my objective is to find this point. And the Excel is based on the area to the left. What is this area here? If I have this right tail, 0.05, this big area must be 0.995. Okay, and then I go to Excel, and this 0.995 is my probability in Excel. Okay, so norm.inv. Okay. NV means critical value, so probability 0.995 mean is 0. Standard deviation is 1. Okay. And you get 2.576. I will also copy down the formula so that you have a reference. So this is the formula, okay? So based on the formula, you get this number. And that number is Z half alpha. Okay, so you have all the numbers you needed to calculate lower bound and upper bound. Okay, so I'm going to present the result. Okay, is here, lower bound, upper bound. Okay. And in summary, what I did in this video is I presented two examples. One example is to test hypothesis test about two population proportions. I used classical method and used p-value method. In classical approach, you compare test statistic with critical value. And in p-value approach, you compare p-value with alpha. If p-value smaller than alpha, reject H0. If p-value greater than alpha, do not reject H0. I also presented another example to construct confidence interval estimate for two population, the difference of two population proportions. Okay, the confidence interval only applies for two-tailed test. Okay. That's all for this video. Thank you so much. I look forward to see you for next video. Hypothesis test about two population means.